Okay, welcome back to part 3 of the Is it food safe? Can it be sanitized? How do things work? Video lecture series for my internship. Now remember, this is for microbiology department as well as the mechanical and aerospace department. There's a lot of information so far covered in the last 45 minutes that you guys have watched. So this is going to be the third and final video to where we've caught up to what we're actually doing. Now there's going to be more videos because we're not fully finished with the entire testing. So today we're going to be discussing 3D printed parts and how they look underneath an electron microscope. Okay, so here is a few images. Now if you look the image on the left, this is actually that metal spoon that I tested in the last video with swab testing to see how much bacteria, so forth, and la-di-da. This is it underneath a digital microscope. Not an SEM because I couldn't cut a small little square out and look at it. This is underneath a digital microscope zoomed into the same number, to the same focus. And you can look at it. I mean, look at this. Where's my mouse? Look at that big giant pore. I mean, that's inside the metal. There's things in the metal there. There's there. Look at all these scratches. Look at this. I mean, that spoon is hammered. Okay? I mean, there's plenty of places for bacteria to grow and hide. And so, knowing how well soapy water and rubbing alcohol does, I mean, I just used soapy water in that, and I was able to clean that spoon. I mean, people are worried about 3D printed parts and bacteria hiding and stuff. Look at these holes. There is stuff, people would have to be concerned about things hiding in there, or a cutting board. I mean, that's terrible. But remember, soapy water can get into holes as small as viruses. That's 0.125 microns. This right here, this hole, where's my mouse again? I gotta see. This is 100 microns. That hole is 10 microns in size. So, soapy water, no problem. Even these smaller ones. I mean, holy crap. Look at these. Okay, now let's look at our 3D printed parts. You got a few surface imperfections. I mean, the 3D printed part is cleaner than the spoon. You got some cusps right here, some gaps right here, but we don't know if those gaps go all the way through. These holes right here, they're dimples, they're not pores, they do not go all the way through the part. In fact, there's actually, when you 3D print, there is no pore that goes all the way through the material. So, they actually are pretty solid. Now we took a piece of this section, put it on its side so we can see how solid the walls are. So this is with a layer of gaps right here, but they are solid right in the center. And so, solid in the sense it is permeable, so I shouldn't say solid, I guess, because when we did water tests, we did a water test and pressure test with 1 wall, 2 wall, and 3 wall. 1 wall failed after about 18 hours of holding water with a little bit of pressure. It failed. 2 walls lasted a couple of days. 3 wall, after 7 days, nothing was happening, so we just stopped. So 3 walls is where we were able to hold water for 7 days without any leaking whatsoever. So, and that was with settings of 0.4 millimeter extrusion width, 15% wall overlap. I have the settings somewhere, I can post them. 0.24 layer height, and a speed of 55 millimeters per second, and a temperature of 210 degrees Celsius with PLA. I did different temperatures with speeds, and every test though was 0.24 layer height. I did some with smaller layer heights, but we still had the same results. So layer height was really not too big of the function. It's more of the temperature and the speed to make sure that you get a good standard. But it's interesting to see how clean 3D printed part underneath an SEM a scanning electron microscope, or SEM, compared to a metal spoon. So kind of a compare and contrast. Now, cutting boards look a lot like 3D printed parts mixed with the the metal spoon, from the knife grooves and everything. And so far we haven't been concerned about even plastic cutting boards that are considered food safe. You still run into the same issue of what this spoon looks like or what this 3D printed part looks like. So what the concern is actually the biofilm from bacteria, and the second major concern is the material itself, the additives from the colors, the additives of the bindings and the glues, and also the nozzle, is it contributing to it to make it not food safe? So where does this take us? So what we're doing now is we're actually inoculating all the parts, 3D printed parts, with E. coli. So this is me taking each, I have hundreds of these 3D printed squares with certain dimensions, all printed at certain settings, and we're inoculating them with E. coli, seeing how much grow just by growing, and then we're going to take those parts, and then we're going to, because I have 10 different bacterias that I've cultured, and one of them is really dangerous, and it's called Pseudomonas. That's how I pronounce it. It's probably pronounced wrong. Anyways, so you take 2 parts cultured with that, let it culture and let the bacteria grow so you can see what it looks like. And then, actually no, let's see, how many cleaning methods do I have? I have water, soapy water, rubbing alcohol, bleach water, and that's it. So I have 4 methods. So I have 6 squares total for each of the 10 bacteria. So that's 60 squares. So I culture all 60 of them, see how well it grows just by itself, and then I clean each one of them in the 4 different ways or 5 different ways I want to clean them, and then see how well the bacteria grow and see what happens. So far, it's been pretty interesting, and we're still getting the results back. This is currently where we're at with the testing the bacteria stage and testing the biofilms. So they're actually culturing right now as we speak. And today's what, the 29th of November? So doing really well. So from here, this is what I want you guys to do. I want you guys to stay tuned because we're getting into the good stuff now. So thank you for watching 45 minutes of preliminary stuff for 10 minutes of awesome stuff. But it's all awesome. Anyways, thank you for watching this. Right now, you can go to these 2 websites, get more information of what I've done with other projects with aerospace. My favorite one so far is working with Granta EDU Pack out in England, helping with the Mars lander. Our team, it was me and 2 others, we helped prove that the material that NASA picked for the Mars lander was the correct material. That was our project for one of the 2 projects for the semester in my advanced materials class. It was really cool. That's on my portfolio. Go ahead and check it out. But stay tuned because we're getting really close to showing how well we can clean these parts and sanitize them and how well these 3D printed things can be food safe, and we're getting really close to seeing if the material itself is actually food safe. So thank you for watching. I'm really excited about this, and thank you for reading all the Facebook posts and staying tuned with this. It's been complicated, I know, and it's been stressful, but thank you all for the support, and I'm excited.